This question here that we're going to look at focuses on integration within a closed interval. It's from the 2019 Higher, paper 1, and it's question number 8 in that paper. So this one here has two parts to it. First one asks us to express the shaded area enclosed between the curves as an integral, and then evaluate the shaded area and calculate it. Now we've got to remember, when we're doing that and we're calculating the area between two curves, we need the points where the two curves intersect because that gives us the limits of our integral. And what we have to do is do the top function, take away the bottom function, so the equation of the top curve, take away the equation of the bottom curve, which will give us the function that we integrate, and then we can evaluate from there. Now in this one we're quite lucky because it tells us it intersects at the points -1 and 2. So we know that already, so we can write away straight away that our area is equal to the integral between -1 and 2. What we now need to do is figure out it's the integral of what between -1 and 2. So we need to figure out the function we're going to be integrating itself. Well, in this case, what we know is we've got to do the top curve take away the bottom curve. Now the top curve is given by this, the bottom curve is given by that. So we know we're going to do x squared plus 2x plus 3 take away the 2x squared plus x plus 1 dx. I can then simplify everything that's in here and make it the integral from -1 to 2. So I've got x squared take away 2x squared, so that's going to give me a minus x squared. I've got 2x take away x, so that's then going to be plus x. I've then got plus 3 take away 1 plus 2 dx. So there you go. That there is going to be the integral to calculate the shaded area between the curves. What I now have to do for part B is evaluate that shaded area. So we've got to use our techniques for integration, and we know when we've got two limits, what we do is we integrate it, calculate it at the upper limit, calculate it at the lower limit, and then subtract them. So first thing is do the integral of that. So from there, I'd be able to say that the area is given by the integral of each term here, so that will be -x cubed over 3 plus x squared over 2 plus 2x between my two limits, which are -1 and 2. What I now do is calculate this at 2, calculate it in -1 and subtract the two of them from each other. So I end up with -2 cubed over 3 plus 2 squared over 2 plus 2 times 2, that's it at the upper limit. Then going to be take away negative of -1 cubed over 3 plus the -1 squared over 2 plus 2 times -1 for the final term in that bracket. So now that I've got this, what I can do is evaluate each bracket and then see what I get as a solution. So this one here, this gives me, so it's -8 over 3. I've then got 2 squared over 2, so that's then plus 2, then plus a 4 from that first bracket. It's then going to be take away, well, -1 cubed is -1, but it's going to be negative of that, so it's then going to be 1 over 3 plus a half take away 2. So if I do each of these brackets on their own, this one here is -8 over 3 plus 2, but remember you've got to represent that as over 3. So -8 over 3 plus 6 over 3 plus 12 over 3. That's -8 plus 6 plus 12. So that's then going to be -8 plus 18. So that one there is going to give me 10 over 3 for this bracket. And then going to be take away this one here. So I've got 1/3 plus a half, then subtract the 2 from that. Now to do it, I've got to represent them all as a common denominator. So this 1/3 would be the equivalent of 2/6. This would become 3 over 6, and that would become -12 over 6. So 2 over 6 plus 3 over 6 minus 12 over 6 gives me -7 over 6. So what I then have to do is add the two of these, because this minus minus becomes a plus. I'll then get 20 over 6 plus 7 over 6. So I get 27 over 6 units squared. And that there is the solution and the area between the two curves. Now I can simplify this. 27 and 6 can both be divided by 3 and rewrite it as 9 over 2 square units. So there you go. We've got our solution for that one there. Always go to the simplest form that you can when it comes to a fraction. Remember, simplify as much as possible. A couple of key things that I want to point out to you here. Firstly, put units squared. Remember, it's an area we're looking at. Areas have units. We need to know what they are. It doesn't give you a defined one, i.e. centimetres or metres, but we need to show that units are included, so put squared units here. Secondly, and a big thing, when you are integrating, you must include the dx. You must include what you are integrating with respect to, otherwise it's meaningless. You would lose the marks here if you did not include your dx as part of that integral. Now this whole part here is worth 1 mark for getting to this stage here, but you would lose that 1 mark if you did not have the dx. If you didn't have it, you would lose a simple mark to get, which could make all the difference. The second part here, what that is that's a 3-mark question. First mark is for simplifying this bit here. So technically you actually get 2 marks for this. Second mark is for integrating it properly. And then third mark is for substituting in and getting your answer here. It's those steps that we have to remember every time when it comes to definite integral. Write it out properly, integrate, substitute. Follow those steps every time. You'll get all the marks that you can from every one of these questions and you'll walk away smiling.